Greetings from Eugene, Oregon. I wanted to do a little piece on capacitors and what happens when you put a dielectric in the capacitor in terms of the charge and the voltage on the capacitor based on whether the capacitor is hooked up to a battery or not. And one of the questions on the homework addresses this. So if this is my capacitor here, it's supposed to be two parallel plates, and I have a battery hooked up to it. So I'll draw the battery here. So let's say I have a voltage V there. Well, what's going to happen is remember there's a capacitance C and there's voltage V. So that means that as a result of this, there's going to be a charge on each plate. On the plus plate, there's going to be a charge Q equals plus CV. On the minus plate, there's going to be a charge Q equals minus CV. And we call this, this is basically just saying that there's a charge of Q equals CV on the capacitor itself, knowing that the plus plate is going to be the plus amount of that charge and the minus plate is going to be the minus amount of that charge. So that's the given when it's hooked up to a battery. If I then take the battery away, let's say, actually no, what I'll do is I will just slide a capacitor in, slide some dielectric material in there, but leave the battery in there. So I'll do it like this. Now I'm going to slide some dielectric material in here. So the question is, what's going to happen now? Now that the dielectric is in here, what I could say is that, well, no matter what, I'm not changing the value of the battery. The value of the battery stays the same. It's still that. So that means that the potential difference across the plates of the capacitor is still V. But what changes is the value of the capacitance C. Basically, when you add a dielectric between two parallel plate capacitors, the new value of C, call it the new value of C, is equal to the value of the dielectric constant times the old value of C. So that means that the C new is greater than the old C. It's bigger. So that the new charge then is going to be equal to the new value of capacitor times the original and the new value of voltage, since the voltage doesn't change. So that means the charge is actually going to increase when you slide the dielectric in there. Alright, so the charge on the plates of the capacitor increases when you do that, when the battery remains connected. So now let's do the similar thing, but let's have the battery not be connected. So if I were to do it that way, I start off with the capacitor, just like I did in the last problem. The capacitor sitting here, hook up a battery to it, whoops. Alright, so I have the battery hooked up to my capacitor, and of course the same thing happens. Charge appears on the plates of the capacitor, like this. And the amount of charge is Q equals CV. It's plus on the left side and minus on the right side. Now let's get rid of the battery. Let's just disconnect the battery before we slide the dielectric in here. So I'm going to get rid of the battery now. No battery. But what happens to the capacitor before I even do anything? Well, it still has a volt potential difference V across here. That hasn't changed. Whoops. It still has a potential difference, or if you like, delta V across the plates. And it still has a charge Q here, and minus Q over here, as it did before when the battery was connected. So now let's slide a little bit of dielectric in here, the same dielectric, and ask what's going to happen in this case with the battery disconnected. So with the battery disconnected, well, there's no battery to add or take away any charge. So with battery disconnected, I could say that charge remains the same. Because the battery is like a repository that can add or take away charge. Here there's just no place for these charges to go. So these charges they're stuck on this plate. They can't go anywhere. There's no place over here for them to go, and they can't cross the plate. That's against the law if they do that. It's a law of physics, let's say. So they're not going to cross the plate here. They're not going to leave the plate, so they're going to stay there. So what's going to happen then when we change the value of the capacitor and we increase it? We increase it just the same now as we did in the last case, because putting a piece of dielectric in there creates a new capacitance. So I can still say that C nu is equal to the value of the dielectric constant times the old capacitor. So that's the new value of capacitance. So therefore I can say that since the charge stays the same, that the voltage is the thing that changes. So the new voltage drop across this capacitor is going to be equal to the charge, which does not change, in this case, as we talked about, divided by the new value of capacitance. So the voltage is going to go down when you slide the dielectric in there with the battery disconnected. With the battery connected, the charge increases. So you're doing the same thing to the capacitor, but whether the battery is connected to it or not affects what happens. Okay, that's enough for now.